Good morning, everybody. Today we will discuss some concepts in electrostatics, also called static electricity. As you know, the study of static electricity begins with frictional electricity, charge developed due to friction. Historically, in 17th century, it was found that when a glass rod is rubbed with silk, it is able to attract small pieces of paper or other light bodies. It might have been thought that there is some chemical reaction between glass and silk responsible for this new property. After several investigations, it was found that there is no sort of chemical reaction between glass and silk. So since there is no chemical change, it was decided that there is some physical change responsible for this new property of the glass rod. It attracts light bodies or small pieces of paper. So, some new physical quantity has been acquired by the glass rod during friction with silk. This new physical quantity was termed charge. This is how the term charge was introduced. So, in this way, due to friction between glass and silk, the glass rod acquires some charge. Once this was decided, scientists tried to develop charge on other bodies. In one such attempt, a plastic rod, or maybe called ebonite rod, rubbed with fur or wool or cat skin, was also found to get charged. Plastic rod rubbed with fur is also able to attract light pieces of paper or some similar bodies. So, plastic rod also gets charged. So, in this way, in 17th century, scientists tried to produce charge on different bodies by suitable friction. Then, experiments were performed to study properties of these charges. Immediate property known was charge on the glass rod or on the ebonite rod is able to attract light bodies. After a number of experiments, it was found that there is some sort of force. It is called interaction force. There is some interaction force between any two charged bodies. The force can be either a force of attraction or a force of repulsion. In this way, through experiments, it was established that between opposite charges there is force of attraction, and between similar charges there is force of repulsion. As I said, charge can be produced on several bodies by suitable friction. Experiments showed that charge on any body is either similar to charge on the glass rod or similar to charge on the plastic rod or ebonite rod. However, charge on the glass rod and charge on the plastic rod were found to be opposite. So in this way, charge on any body is either similar to charge on glass rod or similar to charge on ebonite rod. This shows that there are two types of charges and only two types. There cannot be any third type. Each charge is either similar to charge on glass rod or similar to charge on plastic rod. So it was well established that there are two types of charges having opposite properties. So by convention, charge on glass rod was regarded as positive charge, and charge on the ebonite rod was considered to be a negative charge. So in this way, we have two types of charges termed positive and negative. So what is charge? In fact, we cannot define charge as such. No one has ever seen electric charge. Charge does not have any known weight. It does not have any color, length, width, odor, and so on. So since we cannot see the charge or we cannot feel the charge, it has to be defined in terms of effect of the charge. And simplest effect, as I said, is either attraction or repulsion. So now we can say charge is something that appears on a body due to suitable friction, and it is able to attract light bodies, it is able to attract oppositely charged body, and it can repel similarly charged body. So this is how we introduce the quantity charge. Remember, charge can be produced on any body. Friction between any two bodies will produce charge. But then, why do we always think of glass rod or plastic rod? Yes, it is true that charge can be acquired by a copper rod or aluminum rod or any other. But then, we know copper, aluminum or any other metal is a good conductor. Human body is also a good conductor. So if a copper rod is rubbed by silk or by some other substance, it will acquire charge. But that charge will immediately flow to the earth through human body. This is why we cannot see any charge on metals like copper, aluminum, etc. by friction. But then it is possible. You can have a copper rod supported with some insulating handle, and then if it is rubbed with silk or some other material, it will acquire charge. Charge will be present. Charge can be observed on the copper rod or on any other material. What is the reason of this charge? From where this charge comes? Why it comes and how it comes? According to our present understanding, according to physics that was developed in 20th century, we know that all the material is made of atoms and molecules. Molecule is also a combination of atoms. So we can say that all the matter is basically consisting of atoms of different elements. And what is the constitution of atom? Again, all of you have studied that atom consists of nucleus and electrons moving around the nucleus. The nucleus contains protons and neutrons. Again, you know, neutrons are uncharged. Proton is a positively charged particle. Electron is a particle having negative charge. The atom as a whole is electrically neutral because number of electrons moving in different orbits is same as number of protons in the nucleus. The positive charge on each proton and negative charge on every electron are numerically equal. So because the atom contains equal number of protons and electrons, it of course means that atom contains equal amount of positive charge in the nucleus and equal amount of negative charge in the form of electrons moving around the nucleus. So normally the atom is electrically neutral. Again, you know that electrons are moving around the nucleus in some systematic way. Electrons are distributed in different orbits. So some electrons are moving in inner orbits and some in outer orbits. Particularly the valence electron is moving in the outermost orbit. Now see that there is attraction between negatively charged electron and positively charged nucleus. Now electrons moving in the inner orbit are very close to the nucleus. Obviously, nucleus will produce strong force of attraction on such electrons. And therefore, we say that electrons in the inner orbit are very tightly bound to the atom. There is a large force that holds the atom bound to the atom. However, the situation about valence electrons is somewhat different. Valence electrons are relatively away from the nucleus. Because the distance is greater, force of attraction by the nucleus on such electron is rather weak. So we say that electrons in the outermost orbit or valence electrons are rather loosely bound to the atom. Valence electrons atomला loosely bound आहेत. म्हणजे नेमकं काय? त्या इलेक्ट्रॉनना ॲटम मध्ये धरून ठेवणारी एनर्जी कमी आहे. The energy that holds valence electrons bound to the atom is somewhat smaller. तेव्हा अशा इलेक्ट्रॉनला जर का पुरेची एनर्जी मिळाली तर ते इलेक्ट्रॉन ॲटमला बाउंड राहत नाहीत, ते बाहेर पडतात. If one of the valence electrons gets enough energy, it will no more remain bound to the atom. It can leave the atom. In fact, in every metal, one of the valence electrons leaves the atom and becomes free. एकदा का इलेक्ट्रॉन ॲटम मधून बाहेर पडला की त्याला आपण फ्री इलेक्ट्रॉन म्हणतो. So in every metal there are infinitely many atoms. Number of atoms comparable to Avogadro's number 10 raised to 23 per centimeter cube and so on. From each atom one electron becomes free. So any metal is like ocean of free electrons. Large number of free electrons, infinitely many free electrons are free. In other materials which are not good conductors, still the outermost electron is rather loosely bound. It doesn't have enough energy to leave the atom. इतर मटेरियल मध्ये, मेटल नसलेल्या मटेरियल मध्ये, नॉन मेटल मध्ये आउटरमोस्ट इलेक्ट्रॉन हा न्यूक्लियसला लूजली बाउंड आहे, पण त्याची एनर्जी पुरेशी नाहीये किंवा त्याला धरून ठेवणारी एनर्जी जास्त आहे, त्यामुळे तो ॲटम मधून सहजपणे बाहेर पडत नाही. इन ए नॉन कंडक्टिंग मटेरियल the outermost electron cannot easily leave the atom. It can leave the atom but not easily. So if such an electron gets enough energy from some external source, it can leave the atom and it can be transferred to some other atom. This is what exactly happens during friction. During friction with glass rod and silk, some loosely bound electrons in the atoms of the silk get transferred. After the electrons gets transferred from some body, the charge in the nucleus will be greater. Once the electron leaves the atom, the nucleus will be positive. Positive charge in the nucleus will be greater than total charge of the orbiting electrons. So we say that the atom now carries positive charge. It may be called positive ion. Similarly, the other body which gains electrons, where electrons are transferred, now there will be excess negative charge. Negative charge of the orbiting electrons will be greater than positive charge of the nucleus. So such a body becomes negatively charged. Yes, now you can come to know what exactly happens during friction between glass rod and silk. Due to friction, electrons of the glass rod are transferred to the silk. So in the glass rod, number of electrons is less than what it would have been normally. And that's why glass rod appears to be charged positively. Yes, it is true that on the silk cloth there will be excess electrons, and so it will be negatively charged. तेव्हा अशा प्रकारे ग्लास रॉड आणि सिल्क यांच्या फ्रिक्शनमुळे काय होतं, ग्लास रॉडवरचे काही इलेक्ट्रॉन्स, लूजली बाउंड इलेक्ट्रॉन्स, हे सिल्ककडे ट्रान्सफर होतात. सिल्कच्या इतर ॲटम्सवर ते ॲड होतात. तेव्हा ग्लास रॉडवर एरवी जेवढे इलेक्ट्रॉन दिसले असते त्याच्यापेक्षा कमी इलेक्ट्रॉन्स आहेत आणि म्हणून तो पॉझिटिव्हली चार्ज झाला. अर्थातच सिल्क क्लॉथवर एरवी जेवढे इलेक्ट्रॉन दिसले असते त्याच्यापेक्षा जास्त इलेक्ट्रॉन्स आहेत आणि म्हणून तो निगेटिव्हली चार्ज झाला. सो दिस इज हाऊ वी कॅन इंटरप्रिएट हाऊ चार्ज इज acquired during friction. या ठिकाणी एक लक्षात ठेवायला पाहिजे की ह्या फ्रिक्शनमुळे चार्ज क्रिएट झालेला नाहीये, तर चार्ज फक्त ट्रान्सफर झालेला आहे. चार्ज ग्लास रॉडवर आहेच, पण एरवी पॉझिटिव्ह निगेटिव्ह चार्ज सारख्या प्रमाणात असतात. फ्रिक्शननी काय झालं, ग्लास रॉडवरचे काही इलेक्ट्रॉन्स सिल्क क्लॉथवर ट्रान्सफर झाले आणि म्हणून ग्लास रॉडवर पॉझिटिव्ह चार्ज दिसतोय, पण तेवढाच निगेटिव्ह चार्ज सिल्क क्लॉथवर आहे. सो इन दिस वे, रिमेंबर, whenever a body is electrified by friction, there is separation of charges. Charges are transferred, charges are separated, and charge is not manufactured. Friction is not the only way to produce charge on a body. Charge can be developed on a body by some other mechanisms also. Friction is the most elementary mechanism that we learned. Most elementary mechanism. There are some other ways by which a body can be charged. Here you see some processes. A second way is charging by conduction. A body can be charged if it is put in contact with some other charged body. Suppose a metal sphere is uncharged. If a glass rod with positive charge is touched to that metal body, positive charge of the glass rod will be partly transferred to the metal body and the metal body becomes charged. So here charge is developed by putting an uncharged body in contact with a charged body. Now this contact may be a direct contact. As I said, charged glass rod is touched to a metal body, or the contact can be by means of a metal wire. Suppose one metal sphere resting on insulating stand is charged with the help of a glass rod. Now if this metal sphere is touched to another metal sphere by means of a wire, by means of a conductor, obviously conductor is something through which charge can easily flow. So charge on the first sphere will be transferred to other metal body, other metal sphere. So in this way the other metal sphere will become charged. तेव्हा अशा प्रकारे एखाद्या पदार्थावर चार्ज डेव्हलप करण्याची दुसरी पद्धत काय झाली? चार्जिंग बाय कंडक्शन. एका मेटल स्फिअरवर चार्ज आहे, तो इन्सुलेटिंग स्टँडवर आहे. दुसरा मेटल स्फिअर इन्सुलेटिंग स्टँडवर आहे, त्याच्यावर चार्ज नाही आहे. पण हे दोन्ही मेटल स्फिअर जर एखाद्या वायरनी, एखाद्या कंडक्टरनी जोडले तर पहिल्यावरचा चार्ज काही प्रमाणात दुसऱ्यावर ट्रान्सफर होणार आहे. म्हणजेच ज्या मेटल स्फिअरवर आधी चार्ज नव्हता त्याच्यावर आता चार्ज डेव्हलप झालेला आहे. तेव्हा या ठिकाणी चार्ज कशाने डेव्हलप केलाय आपण? बाय कंडक्शन. दोन पदार्थ एकमेकांच्या कॉन्टॅक्ट मध्ये असताना जी चार्ज ट्रान्सफर होते त्याला आपण कंडक्शन म्हणतो. सो इन दिस वे सेकंड मेकॅनिझम to develop charge on a body is by conduction. What is conduction? Charge transferred by one body to the other due to a physical contact, either directly or with the help of a wire, with the help of a conductor. So this process is called conduction. There is a third and more important way or a process by which a body can acquire charge. This third mechanism is called charging by induction. Charging by induction is somewhat different from charging by conduction. As you see here, in charging by induction, a charged body A can impart charge of opposite sign to another body B without any contact between the two. There is no contact. A body A has imparted charge to another body B, but there is no contact. And because there is no contact, charge on the body A is not altered. Charge on the body A remains unchanged. Induction मध्ये काय होतं? एखाद्या बॉडीकडून, समजा ए ह्या बॉडीकडून बी ह्या बॉडीकडे विरुद्ध प्रकारचा चार्ज दिला जातोय. असं करताना ए आणि बी मध्ये कोणताही कॉन्टॅक्ट नाहीये आणि कॉन्टॅक्ट नसल्यामुळे ए वरचा चार्ज हा काही बदलत नाही. ए वरचा चार्ज तसाच राहतोय पण बी वर चार्ज दिला जातोय. हे इंडक्शन काय आहे बघा, या फिगर वरून कळेल. व्हॉट इज इलेक्ट्रोस्टॅटिक इंडक्शन? यू कॅन सी फ्रॉम these figures. In the first figure A, a metal sphere is resting on an insulating stand. That is figure A. In figure B, a charged plastic rod or ebonite rod is brought close to the metal sphere. Obviously, plastic rod carries negative charge. या B फिगर कडे नीट पहा. चार्ज प्लास्टिक रॉड या मेटल स्फिअर जवळ आणलेला आहे. काय होणार याच्यामुळे? मेटल स्फिअर आहे. मग अशी म्हणल्याप्रमाणे मेटल स्फिअर त्याच्यामध्ये असंख्य फ्री इलेक्ट्रॉन्स आहेत. आणि फ्री म्हणजे काय? जे आपली जागा सोडून इतरत्र जाऊ शकतात. The metal sphere contains large number of free electrons. Free, that means they can move. So now what will happen due to presence of charged plastic rod? Negative charge on the plastic rod will repel electrons in the metal sphere. So electrons will quickly move away from negative charge on the plastic rod. So electrons will be shifted, electrons will be displaced to the opposite end away from plastic rod. Now there are more electrons on the opposite end. It means that opposite surface has become negatively charged. On the other hand, the surface close to the plastic rod contains less number of electrons than what it would be otherwise. So number of electrons is less. There is a deficiency of electrons. This of course means that the face nearer to the plastic rod has acquired positive charge. तेव्हा अशा प्रकारे प्लास्टिक रॉड वरच्या निगेटिव्ह चार्ज मुळे मेटल स्फिअर मधले इलेक्ट्रॉन्स लांब गेले. म्हणजेच प्लास्टिक रॉड पासून लांब असलेल्या सरफेसवर निगेटिव्ह चार्ज निर्माण झाला आणि प्लास्टिक रॉडच्या जवळ जे सरफेस आहे तिथे इलेक्ट्रॉन्सची उणीव आहे, कमी आहेत. म्हणजेच या सरफेसवर पॉझिटिव्ह चार्ज निर्माण झाला. नाउ लुक ॲट फिगर सी. द सरफेस away from plastic rod is connected to ground. This is also called earth connection, ground connection. प्लास्टिक रॉड पासून लांब असलेलं सरफेस जमिनीला जोडलेलं आहे, ग्राउंडला किंवा अर्थला जोडलेलं आहे असं म्हणण्याची पद्धत आहे. म्हणजे नेमकं काय करायचं तर साधी वायर घेऊन आपल्या पाण्याच्या नळाला जोडली तरी चालेल, कारण नळ हा जमिनीत पुरलेला असतो, कुठेतरी अर्थशी त्याचा कॉन्टॅक्ट असतो. सो टू मेक ए ग्राउंड कनेक्शन ए वायर can be joined between opposite surface of metal sphere and some water pipe, gas pipe, etc., which is well buried in the earth somewhere. What happens due to this? The free electrons on the opposite surface will quickly move to the ground, will quickly move to the earth. प्लास्टिक रॉड पासून लांब असलेल्या सरफेसवरचे ज्यादा इलेक्ट्रॉन्स हे जमिनीकडे निघून जातील. दिस इज व्हॉट इज शोन इन फिगर सी. नाउ that earth connection or ground connection is removed. Observe that positive charge does not go to the earth. Why? Because positive charge remains there due to attraction with negative charge on the plastic rod. पॉझिटिव्ह चार्ज काही जमिनीत निघून गेलेला नाहीये. कारण काय तर हा जो पॉझिटिव्ह चार्ज आहे तो प्लास्टिक रॉड वरच्या निगेटिव्ह चार्जच्या अट्रॅक्शन मुळे तिथे राहिलेला आहे, तो लांब जाणार नाही. दिस इज शोन इन फिगर डी. अर्थ कनेक्शन इज रिमूव्ड and positive charge remains on the surface nearer to the plastic rod. Now after this, remove that plastic rod. The positive charge that was there on the surface nearer to the plastic rod will now distribute equally, uniformly. This is shown in figure E. So figure E मध्ये काय दिसतंय तर जो पॉझिटिव्ह चार्ज प्लास्टिक रॉडच्या जवळच्या सरफेसवर होता तो पॉझिटिव्ह चार्ज आता सगळीकडे सारख्या प्रमाणात पसरलेला आहे. सो इन दिस वे द मेटल स्फिअर हॅज बीन चार्ज्ड. हाऊ? बाय द प्रेझेन्स ऑफ ए चार्ज्ड प्लास्टिक रॉड. Plastic rod was negatively charged and it has imparted positive charge to the metal sphere. This is why I said a charged body can impart a charge of opposite sign to another body, and in this entire process there is no contact between plastic rod and the metal sphere. तेव्हा ही जी क्रिया आहे त्याला म्हणायचं चार्जिंग बाय इंडक्शन. आणखी एक उदाहरण पहा, चार्जिंग बाय इंडक्शन. Now the figure that you are seeing here, there are two metal spheres A and B. they are resting on insulating supports and the two metal spheres are in contact. A and B are in contact. Once again, a charged plastic rod is brought close to metal sphere B. As before, due to repulsion of this negative charge on the plastic rod, electrons in the metal sphere B will move away. Now A and B metal spheres are in contact. So as if AB is a single metal body. So electrons on the surface of sphere B close to the plastic rod will move as away from the negative charge as possible. So the electrons will go to opposite surface of sphere A. तेव्हा अशा प्रकारे प्लॅस्टिक रॉड वरच्या निगेटिव्ह चार्ज मुळे काय झालेलं आहे, प्लॅस्टिक रॉडच्या जवळ जे सरफेस आहे स्फिअर बी त्याच्यावर इलेक्ट्रॉन्स कमी आहेत, म्हणजे पॉझिटिव्ह चार्ज निर्माण झाला. आणि ए मेटल स्फिअरच्या ऑपोजिट सरफेसवर प्लॅस्टिक रॉड पासून लांब असलेल्या सरफेसवर इलेक्ट्रॉन्स जमा झालेले आहेत, म्हणजे निगेटिव्ह चार्ज डेव्हलप झालेला आहे. सो इन दिस वे, by the presence of negatively charged plastic rod, we have positive charge on metal sphere B on the surface close to the plastic rod, and we have equal negative charge on metal sphere A on the surface away from plastic rod. Now in figure B, imagine that the spheres A and B are separated. आता आपण A आणि B मेटल स्फिअर सेपरेट केले. सो पॉझिटिव्ह चार्ज स्टील रिमेन्स ऑन स्फिअर B on the surface close to plastic rod. Negative charge still remains on sphere A on the surface away from plastic rod. There are two possibilities. One way is, as before, negative charge on metal sphere A can be removed by connecting it to the ground. Instead of using a metal wire, a person can simply touch the metal sphere A. As I said, human body is a good conductor, so if you touch the sphere A by finger, the charge will go to the earth. And now the sphere B will continue to acquire positive charge even if that plastic rod is removed. This is shown in the next figure. So if we remove negative charge by connecting it to the earth and then separate, there will be positive charge on both spheres A and B. That is shown in the last figure. Figure मध्ये शेवटी काय दिसतंय, A आणि B कॉन्टॅक्ट मध्ये दोन्हीवर पॉझिटिव्ह चार्ज आहे. प्लॅस्टिक रॉड आता काढून घेतलाय, लांब नेलेला आहे. ए आणि बी जरी सेपरेट केले तरी दोन्हीवर पॉझिटिव्ह चार्ज दिसेल. Instead of using negatively charged plastic rod, equally well we can use positively charged glass rod. By induction, it can impart negative charge to other bodies, to a metal sphere or any other body. Incidentally, here I have used the word earth, ground connection, earth connection. What is this earth connection or ground connection, and why the charge flows to the earth? First of all, the earth is a huge body. It contains infinitely many atoms and molecules. So it is an ocean of positive charge as well as negative charge. Infinitely huge amount of positive and negative charges are present in the earth. Now, when I say infinite, you might be knowing that infinity plus something is infinity. There cannot be any change. Infinity minus something is infinity. For example, say water in the ocean, Pacific Ocean, infinite. If you add 3-4 buckets of water to the ocean, its level is not going to rise. Or if you remove few buckets of water from the ocean, its level is not going to reduce. तेव्हा समुद्रात आपण काही बादल्या पाणी ओतलं काय किंवा काही बादल्या पाणी काढलं काय, त्यातल्या पाण्यात काही बदल होत नाहीये. तसंच अर्थला कितीही चार्ज दिला तरी ती न्यूट्रलच राहणार आहे, कारण त्याच्यात आधीच इन्फानाइट अमाऊंट ऑफ चार्ज आहे. अर्थमधून कोणताही चार्ज काढून घेतला किंवा ऍड केला तरी त्याच्यामध्ये कोणताही फरक पडत नाही. सो एनी अमाऊंट ऑफ चार्ज either positive or negative can be given to the earth and still it remains electrically neutral. One more thing, potential of earth is zero. Earth's potential zero असतं. So whenever any body is touched to the earth, it means the body is given a negative, a zero potential. The body acquires no potential. तेव्हा कोणताही पदार्थ जमिनीशी जोडला म्हणजे त्याचं पोटेन्शियल झिरो झालं. सो दिस इज हाऊ चार्ज कॅन बी गिव्हन टू ए बॉडी आयदर बाय फ्रिक्शन और बाय कंडक्शन और बाय इंडक्शन. नाउ लेट अस सी व्हाट आर द प्रॉपर्टीज ऑफ इलेक्ट्रिकल चार्जेस. वन प्रॉपर्टी we already discussed, or through this property we get acquainted with what is charge. The first property is attraction or repulsion. Most basic property, most elementary property is there is attraction between opposite charges and repulsion between similar charges, like charges. Second property, additivity. Very simple. If we have charge Q1 from one source, charge Q2 from another source, total charge will be Q1 plus Q2. In this way, many charges can be added. If we have charges Q1, Q2, Q3, etc., total charge of the system will be Q1 plus Q2 plus Q3 and so on. This of course means that charge is a scalar, similar to mass. M1 and M2 masses put together, total mass is M1 plus M2. Similarly, charge Q1 and charge Q2 taken together, total is Q1 plus Q2. So many times we have comparison between charge and mass. We are not concerned with today, but many times mass is called gravitational charge. आज आपण विचार करत नाहीये, पण बऱ्याच वेळेला ही सिमिलॅरिटी असल्यामुळे मासला ग्रॅव्हिटेशनल चार्ज म्हणतात. Anyway, our property is additivity. Yes, although there is similarity between mass and charge, we have to remember mass is mass, only one type. There is nothing like positive mass and negative mass. But charge can be positive or negative. So additivity, addition is algebraic. We have to consider sign. We may have a charge say 10 units and another charge minus 3 units. Added together, we'll get 7 units. 10 plus minus 3. So it is algebraic sum, that is sum after taking into account positive or negative sign. So this simple property is called additivity. Third property, also we have studied in our earlier discussion, conservation. Conservation means total charge of a system remains constant. Charge cannot be created. Charge cannot be destroyed. All that is possible is transfer of charge, rearrangement of charge between different bodies in the system. So this property is called conservation. Conservation म्हणजे कोणत्याही सिस्टीमचा एकूण चार्ज कॉन्स्टंट असतो, तो कमी होत नाही किंवा वाढत नाही. चार्ज नव्याने निर्माण होत नाही किंवा असलेला चार्ज नाहीसा होत नाही, फक्त चार्ज ट्रान्सफर होतो. एका पदार्थाहून दुसऱ्या पदार्थाकडे चार्ज ट्रान्सफर होतो किंवा चार्जची रिअरेंजमेंट होते, त्याला म्हणायचं कॉन्झर्वेशन. नेक्स्ट प्रॉपर्टी, थोडासा कॉम्प्लेक्स शब्द वाटतोय, क्वांटायझेशन. त्याचा अर्थ मात्र अगदी सोपा आहे. मगाशी मी जे सांगितलं की प्रत्येक चार्ज हा इलेक्ट्रॉन ट्रान्सफर झाल्यामुळे डेव्हलप होतो. ज्याच्यावर इलेक्ट्रॉन ट्रान्सफर झाले तो पदार्थ निगेटिव्हली चार्ज आणि जिथून इलेक्ट्रॉन्स ट्रान्सफर झाले तो पॉझिटिव्हली चार्ज. आपल्याला माहिती असेल की एका इलेक्ट्रॉनवरचा चार्ज 1.6 इंटू 10⁻⁻19 कुलॉम एवढा आहे. मग इतर कोणत्याही पदार्थावरचा चार्ज इलेक्ट्रॉन्स एक्सेस जादा असल्यामुळे किंवा इलेक्ट्रॉनची डेफिशियन्सी असल्यामुळे निर्माण होतोय. एव्हरी चार्ज ऑन एनी बॉडी is either due to excess electrons or due to deficiency of electrons. There are n excess electrons. The negative charge will be n times electronic charge. So here I have written Q equal to n into E. E ची व्हॅल्यू लिहिताना फक्त 1.6 into 10⁻⁻19 कुलॉम अशी लिहिली जाते. इलेक्ट्रॉनवरचा चार्ज मायनस ई, प्रोटॉनवरचा चार्ज ई किंवा प्लस ई. सो एव्हरी पॉझिटिव्ह चार्ज हॅज टू बी इंटिग्रल मल्टिपल ऑफ ई, वेअर ई इज 1.6 into 10⁻⁻19 कुलॉम. एव्हरी निगेटिव्ह चार्ज हॅज टू बी n into ई. तेव्हा चार्ज 12 ई असेल, 15 ई असेल, 200 ई असेल, किती मोठा नंबर इंटू ई असेल. पण असं कधी होणार नाही एखाद्या पदार्थावरचा चार्ज 9.2 ई आहे किंवा 10.7 ई आहे. इम्पॉसिबल. तेव्हा चार्ज हा काय असला पाहिजे, ईच्या पूर्णांक पटीतच असला पाहिजे. यालाच म्हणतात क्वांटायझेशन. एनी चार्ज हॅज टू बी इंटिग्रल मल्टिपल ऑफ ई. ई इज इलेक्ट्रॉनिक चार्ज, बेसिक चार्ज. So this property is called quantization. Q must be n into E, where n is a natural number. N cannot contain any fraction. खरं म्हणजे हे थोडं अर्धसत्य आहे म्हणलं तरी चालेल. According to recent developments in physics, scientists have discovered particles called quark having charge 2/3 E or 1/3 E numerically. But let us leave that aside for our today's discussion. So except in nuclear physics or atomic physics where we come across quarks, very rarely we come across this. So we can say that every charge is integral multiple of electronic charge. खरं म्हणजे ज्या वेळेला आपण मेटल स्फिअर वरचा चार्ज किंवा ग्लास रॉड वरचा चार्ज विचारात घेतो त्यावेळेला एन एवढा मोठा असतो की ह्या चार्जचं क्वांटायझेशन विचारात घेण्याची जरूर पडत नाही. इलेक्ट्रॉनचा चार्ज काय आहे, 1.6 into 10⁻⁻19. So if we are considering charge on atom, charge on ion, charge, total charge of some molecule, we have to consider this quantization. But if we are dealing with a quantity of charge very much greater than charge of electron, then this quantization has no significance. This is called macroscopic level. Macroscopic, not microscopic. If we are considering charge on atom, charge on ion, charge of molecule, that is microscopic level. But at macroscopic level, where charges involved are much greater than charge of electron, this quantization has no significance, so we can ignore. But it is true that charge is quantized. That means any charge is integral multiple of electronic charge. But then at macroscopic level, when we are considering charge much greater than electronic charge, this quantization may be ignored. Some more properties are more important. Look here, property number 5. Whenever charge is given to a conductor, the charge entirely lies on the outer surface of a conductor. There cannot be any charge in the interior of the conductor. Conductor may be solid or it may be hollow. कोणत्याही कंडक्टरला चार्ज दिला, कितीही चार्ज दिला तो सगळा चार्ज त्या कंडक्टरच्या आउटर सरफेसवर असणार आहे. कंडक्टरच्या आतमध्ये कधीही चार्ज असत नाही. दिस हॅज बीन प्रूव्ड एक्सपेरिमेंटली. इवन यू कॅन टेस्ट दिस experimentally if you have suitable instruments. For the time present, just remember that charge given to a conductor resides completely on the outer surface of the conductor. There cannot be any charge in the interior of the conductor. थोडं रफली असं सांगता येईल की कंडक्टरमध्ये फ्री इलेक्ट्रॉन्स आहेत. कंडक्टरला आपण चार्ज दिला, कंडक्टरला दिलेला चार्ज हा देखील असंख्य इलेक्ट्रॉनचा बनलेला आहे. इलेक्ट्रॉन जादा असल्यामुळे किंवा कमी असल्यामुळे. सिमिलर चार्ज मध्ये रिपल्शन आहे आणि त्यामुळे काय होईल, हे सगळे जादा इलेक्ट्रॉन्स आहेत एकमेकापासून लांब पळतील. रिपल्शनमुळे एकमेकापासून लांब पळत पळत जास्तीत जास्त अंतरावर राहायचा प्रयत्न करतील. आणि जास्तीत जास्त अंतरावर केव्हा असतील, तर हे जादा इलेक्ट्रॉन सगळे कंडक्टरच्या बाहेरच्या सरफेसवर आल्यावर. सो रफली वी कॅन से that it is due to mutual repulsion between similar charges. Because of repulsion, similar charges will try to run away from one another and they will try to keep maximum separation. And obviously, separation will be maximum when charges are on the outer surface of the conductor. In other words, we also say that because there is no charge in the interior of the conductor, there is no electric field in the interior of the conductor. Electric field inside a conductor is essentially zero. कंडक्टरच्या आतमध्ये इलेक्ट्रिक फील्ड कधीही असत नाही. चार्ज नाहीये म्हणजेच इलेक्ट्रिक फील्ड नाहीये. याचं महत्व शेवटी परत त्याला सांगेन मी. नेक्स्ट प्रॉपर्टी, हाऊ चार्ज इज डिस्ट्रीब्युटेड on the surface of a conductor. कंडक्टरला दिलेला चार्ज आउटर सरफेसवर आहे खरंच आहे, पण मग सगळीकडे सारख्या प्रमाणात आहे का? इज इट दॅट चार्ज ऑन द आउटर सरफेस इज डिस्ट्रीब्युटेड इक्वली एव्हरीवेअर? नो. इफ वी कन्सिडर स्फियर, देन ओके, चार्ज विल बी सेम एव्हरीवेअर. चार्ज विल बी डिस्ट्रीब्युटेड इक्वली ऑन द सरफेस ऑफ ए स्फियर. But if we consider a conductor of some other shape, not spherical, then charge has some definite distribution. It is not distributed uniformly. It is not distributed equally. So in this figure, you see a conductor. Imagine that this is a conductor. This can be called pear-shaped conductor, resting on insulating support. Charge is given to this. या फिगर मध्ये पियर शेप म्हणतात त्याला. पियर शेपचा कंडक्टर इन्सुलेटिंग सपोर्टवर आहे आणि त्याला चार्ज दिलेला आहे. मग आता का बरं चार्ज सगळीकडे सारखा असत नाही? कारण अगदी सोपं आहे. यू नो दॅट चार्ज मूव्स फ्रॉम हायर पोटेन्शियल टू लोअर पोटेन्शियल. चार्ज मीन्स पॉझिटिव्ह चार्ज. निगेटिव्ह चार्ज has natural tendency to move from lower potential to higher potential. And in any conductor, there are free electrons. So electrons will always move from lower potential to higher potential. When we say electrostatics, statics means there is no motion of charge. There is no continuous motion of charge. Charge can move for a fraction of a second, for a moment. There can be momentary transfer of charge, but there is no continuous motion. So when the charges are at rest, there is no motion. It means potential everywhere must be same. ज्या अर्थी चार्जची मोशन नाहीये, चार्ज आहे पण मोशन नाहीये, म्हणजेच काय, पोटेन्शियल सगळीकडे सारखं असलंच पाहिजे. कारण जर पोटेन्शियल सारखं नसतं तर इलेक्ट्रॉन्स कमी पोटेन्शियल कडून जास्त पोटेन्शियल कडे भराभरा पळायला लागले असते. पण चार्ज स्थिर आहे असं आपण गृहीत धरलेलं आहे, तेव्हा कंडक्टरवर सगळीकडे पोटेन्शियल सारखं असलंच पाहिजे. बिकॉज we assume or we know that charges are at rest, there is no motion of charge. It means everywhere potential on the conductor must be same. Let us introduce some simple physical quantities to understand this. We define what is called surface density of charge. Surface density of charge denoted by letter sigma. Surface density means charge per unit area. So you see the equation, sigma equal to Q upon A. Q charge is present on surface of area A. So surface density is Q upon A. डावीकडे जे सिम्बॉल दाखवलंय त्याला ग्रीक लेटर सिग्मा म्हणतात. कदाचित आपल्याला माहिती नसेल, आपण समेशन साठी सिग्मा वापरतो. तो अपर केस सिग्मा, मोठा सिग्मा, कॅपिटल सिग्मा काही म्हणा, आणि हा लोअर केस सिग्मा आहे. या ठिकाणी दाखवलेला सिम्बॉल लोअर केस सिग्मा. So surface density of charge denoted by sigma is Q upon A, charge per unit area. Then look at the next equation. To keep the potential equal, the relation is sigma 1 R1 is equal to sigma 2 R2. R1 R2 radius of curvature. Sigma 1 sigma 2 surface density of charge. Now look at the figure carefully. डावीकडे पियर शेपचा कंडक्टर दाखवलेला आहे आणि उजवीकडे पहा जरा, आपण अनेक सर्कल्स दाखवलेले दिसत आहेत. 3 डायमेन्शनल स्पेस मध्ये ही स्पियर्स आहेत. ऑन लेफ्ट हँड साइड यू सी ए पियर शेप्ड कंडक्टर. ऑन द राइट साइड यू सी डिफरंट सर्कल्स. These circles are spheres. So left side of that pear shaped conductor is a part of sphere of some radius. Then look at the bigger circle, biggest circle. It has greater radius. So lower portion of the pear shaped conductor is part of circle of large radius. And then look at the right side. The right end of pear shaped conductor is a part of circle having very small radius. तेव्हा या ठिकाणी 3 स्फिअर दाखवले, 3 वेगवेगळे पार्ट विचारात घेतलेले. मग काय लक्षात येतं, हा जो पियर शेपचा कंडक्टर आहे त्याचं डाव्या बाजूचं सरफेस हे एका स्फिअरचा भाग आहे, त्याची रेडियस मॉडरेट आहे. खालचं जे सरफेस आहे इन्सुलेटिंग स्टँडच्या जवळचं, तो स्फिअरचा पार्ट आहे, पण त्या स्फिअरची रेडियस खूपच मोठी आहे. आणि उजव्या बाजूला जो पार्ट आहे तो देखील स्फिअरचा पार्ट आहे, पण तिथे रेडियस मात्र खूपच कमी आहे. सो इफ यू ऑब्झर्व केअरफुली यू विल फाइंड दॅट फॉर द पियर शेप्ड कंडक्टर लेफ्ट एंड is part of sphere of some moderate radius. Lower side is a part of sphere having large radius. Right side is a part of sphere having small radius. Now look at the equation. Sigma 1 R1 equal to sigma 2 R2 because potential everywhere is same. It of course means sigma 1 upon sigma 2 is R2 upon R1. That means surface density of charge is inversely proportional to radius. Therefore, for the lower part of pear-shaped conductor, radius is large. Radius large means surface density is small. So you see quite a small charge on the lower part. Left side surface, it is part of sphere of moderate radius. So radius is moderate. So surface density of charge is greater than what it is on the lower side. And then at the right extreme, radius of curvature is very, very small. Radius is very small, so surface density is large. So whatever charge is given to the pear-shaped conductor, large part is at the right hand side, somewhat smaller at the left side, and very small at the bottom side or top side. So distribution of charge is not uniform. More charge where radius is smaller, less charge where radius is greater. Now if we imagine a conductor having a needle-like point, at the needle-like point radius is almost zero. Radius is very small, nearly zero. Radius very small, so 1 upon r will be infinitely large. So if a conductor has pointed end, the surface density of charge will be very, very large, extremely large. So in this way, distribution of charge is not uniform. We'll come to this again after a few minutes. Before that, let us become familiar with an instrument used to detect electric charge. चार्ज आहे की नाही आणि किती प्रमाणात आहे हे दाखवणारं एक सिंपल इन्स्ट्रुमेंट, त्याला म्हणतात इलेक्ट्रोस्कोप. इलेक्ट्रोस्कोप इज अन इन्स्ट्रुमेंट used to detect presence of electric charge. There are many types of electroscopes. The most common is gold leaf electroscope. In this figure, what you see is gold leaf electroscope. Now you see a rectangular box, rectangular shape, has no significance, it can be circular also, convenience only. So here you see a rectangular box. At the center of the box there is a metal rod. Metal rod is inserted in the box through an insulating support, rubber say. This rod has a spherical knob at the upper end, metal knob. It is metal. Metal rod having a metal sphere at the upper end. It is called metal knob. At the lower end, there are two very, very thin gold strips. These are called gold leaves supporting from the metal rod. It is shown more clearly on the lower part of the box. त्या बॉक्सच्या खाली दाखवलेलं आहे मेटल रॉडवर गोल्डच्या दोन व्हेरी थिन पॉइंट्स, त्याला लीव्ज म्हणतात, गोल्डची पानं, मराठीत सुवर्णपत्र म्हणतात. अशी दोन कॉइल्स ही सपोर्ट केलेली आहेत मेटल रॉडला. The box is only to protect the leaves from air current, corrosion and so on. Now how this instrument can detect charge? If a charged glass rod is touched to the metal knob, that is shown at the right side, the charge on the glass rod will be given to the metal knob, and it is a metal rod, so charge will go to the gold leaves through the metal rod. Since the two leaves both acquire positive charge because of repulsion between similar charges, the leaves will diverge. या मेटल नॉबला आपण चार्ज ग्लास रॉड टेकवला तर तो चार्ज मेटल रॉड मधून या गोल्ड लीव्सना जाणार आहे आणि दोन्ही गोल्ड लीव्हना पॉझिटिव्ह चार्ज मिळाल्यामुळे काय होणार आहे, रिपल्शन आहे, आणि त्यामुळे ही पानं एकमेकापासून लांब जाणार आहेत, त्याला डायव्हर्जन्स म्हणतात. सो देयर इज अ डायव्हर्जन्स. सो इन दिस वे व्हेनेवर वी सी डायव्हर्जन्स वी कम टू नो दॅट देयर इज चार्ज. जर का त्या ग्लास रॉडवर चार्ज नसता तर असं डायव्हर्जन दिसलं नसतं. सो वेदर ए बॉडी चार्ज ऑर नॉट वी कॅन टेस्ट. टच दॅट बॉडी टू द मेटल नॉब. If you see that gold leaves diverge, then we conclude that there is charge. If the metal leaves remain intact, then there is no charge. It is not always necessary that glass rod is touched to the knob, as we said, by induction. Even if we bring that glass rod close to the knob, then charge of opposite type will be induced on the metal knob. That charge will once again go to the gold leaves and they will show divergence. This electroscope can be also used to detect whether charge on a body is positive or negative. First, the gold leaf electroscope is charged by a known charge, say charge from glass rod. A glass rod with positive charge is touched to the knob. Now we know that the leaves are carrying positive charge and there is some divergence. Now we have some other body having charge. We want to test whether it is positive or negative. Now that other body is touched to the knob. If the charge is positive, then that positive charge will be added to the charge that was already present. So divergence will increase. On the other hand, if the charge body is negative, then positive charge on the gold leaves will decrease and divergence will be less. the leaves will collapse. त्या मेटल नॉबवर आपण दुसरा पदार्थ टच केलेला आहे, त्याच्यावर जर निगेटिव्ह चार्ज असेल तर काय होणार आहे, आधीचा पॉझिटिव्ह चार्ज कमी होणार आहे, म्हणजेच डायव्हर्जन्स कमी, गोल्ड लीव्स जवळ येतील. सो इन दिस वे, बाय ऑब्झर्विंग द स्टेटस ऑफ द गोल्ड लीव्स, whether there is divergence, whether the divergence increases, decreases, or whether there is no divergence, we can understand whether a given body is charged, whether it carries positive charge or negative charge. So such an instrument is called gold leaf electroscope. In fact, nowadays it's a museum piece because there are so many sophisticated electronic instruments that can detect charge, that can measure charge. So this is only of historical importance, but still many times we have a reference to this gold leaf electroscope. When you say electrostatics or static electricity, many of us are interested in this natural phenomena, lightning. आकाशात आपण विजा बघताना पाहतो, सध्याच्या पावसाळ्यात नेहमीच दिसत आपल्याला. हा काय आहे? What is this lightning? Why it is formed? How it is formed? Let us try to understand. First of all, you know that during monsoon season there are clouds, huge clouds, and the clouds are moving by air current. वाऱ्यामुळे हे मोठमोठे ढग हिंडत असतात. So because these clouds are moving due to air currents, there is friction between the clouds. Because of friction, charges are developed. Friction मुळे ढगांमध्ये अशा प्रकारचा चार्ज निर्माण होतो. Clouds are huge. The size of each cloud can be kilometer. The dimensions of the cloud can be in kilometers. So huge amount of charge is developed. So in the first figure, say figure A, you see a cloud. Distribution of charge in the cloud is rather complex. If you see carefully, there is large positive charge denoted by P, uppercase P, capital P, on the upper end. Large negative charge denoted by N on the lower end. And at the corner, at the lower side, there is some positive charge also denoted by small p, lowercase p. So in the cloud, huge positive charge at upper end, huge negative charge at the lower end, and some relatively smaller positive charge. The reason for this distribution of charge is rather complex and not completely understood, we may say. But then, when the conditions are favorable, electrons in the cloud start moving towards the positive charge on the lower side. The electrons continue to move and they come out of the cloud also, that you see in figure B. Electrons continue to move down through air because of huge charge. Air becomes conducting. Normally air is insulating, but because of strong electric field, I'll make it clear within few minutes, the air becomes conducting and charge starts moving down. Then in figure C, you also see induced positive charge on the earth. Earth, and then what is shown, maybe a building, maybe a tree, or something similar, some similar structure. So huge positive charge will be induced in the earth. Now the potential difference between negative charge of the cloud, lower end of the cloud, and positive charge of the earth, potential difference is tremendously large, 100 million volts or more, 10 raised to 8 volts. Because of this huge potential difference, electric field is strong, air becomes conducting, and suddenly the charge moves to the earth, and we say there is a lightning flash. वीज चमकली म्हणतो आपण. ढगातला अख्खा निगेटिव्ह चार्ज क्षणार्धात जमिनीवर आलेला आहे. पोटेन्शियल डिफरन्स लार्ज झाल्यामुळे, एअर कंडक्टिंग झाल्यामुळे क्षणार्धात जमिनीवर आलेला आहे. सो ह्यूज चार्ज फ्रॉम द क्लाउड moves to the earth in a fraction of a second. This is what we mean by lightning flash. And as you know, this is dangerous, troublesome, or property for human beings and so on. So this is what we call lightning. So in this way, lightning is due to huge amount of charge developed in clouds because of friction. The charge is something like 30 coulomb charge. 30 coulomb charge, 20-30 coulomb charge, moving under potential difference 10 raised to 8 volt. How much is energy? Just imagine. In fraction of second, the energy that is developed or energy that is that results from lightning flash, it is something like 100 watt bulb lighting for 1 year, 24 hours, day and night. 100 वॅटचा बल्ब दिवस रात्र आपण जवळ ठेवला तर वर्षभरात जेवढी वीज लागेल तेवढी वीज फ्रॅक्शन ऑफ सेकंड मध्ये या ढगातून आलेली आहे. Then we have something like lightning protector. Lightning protector. Again, see some equations to understand this. In the first equation, I have said electric field intensity. Intensity of electric field denoted by E is proportional to sigma. And energy of the electric field is proportional to E square. You will understand what is the significance of these equations. Now, again, the figure shows a cloud. On the earth, there is some building, and the building is protected by means of a metal rod. A metal rod is buried in the earth, and it is over the building. At the upper side, the metal rod has spikes, sharp ends. त्या बिल्डिंगवर मेटल रॉड आहे. मेटल रॉडचं खालचं टोक जमिनीच्या कॉन्टॅक्ट मध्ये आणि वरच्या टोकाला अनेक शार्प पॉइंट्स आहेत. पॉइंटेड स्पाइक म्हणतात त्याला. As I said before a few minutes, at sharp points, surface density of charge is very, very large. Sigma is very large. Radius of curvature is almost zero, very small. So sigma is very large. At each sharp end, sigma is very large. Sigma large, so the first equation shows E will be very large. E is large, so second equation shows E square is large. What is significance of large E square? Energy of the electric field is large. Electrons of air molecules receive this energy, and this energy is sufficient to overcome binding of the atom, and electrons will become free. हवेतल्या मॉलिक्युल्सचे इलेक्ट्रॉन फ्री झालेले आहेत. अर्थातच राहिलेला मॉलिक्यूल हा पॉझिटिव्ह आयन झाला. सो इन दिस वे एअर बिकम्स गुड कंडक्टर. नॉर्मली एअर इज इन्सुलेटिंग, but because of very strong electric field, because of large surface density of charge, air becomes conducting. So in this way, positive charge induced in the earth will leak in the atmosphere. Really, positive charge leaks means electrons are taken. Electrons are taken. So slowly electrons from the cloud are taken, and they will neutralize the positive charge leaking from the atmosphere. How this protects the building from the lightning? Because now continuously charge from the electrons is moving to the earth. So instead of sudden lightning flash, the charge in the cloud goes slowly, continuously. So instead of sudden lightning flash, there is continuous discharge of the cloud. क्षणार्धात ढगातला चार्ज जमिनीवर येण्याऐवजी तो थोडा थोडा एकसारखा हा जमिनीत निघून जातोय. कशामुळे जमिनीत निघून जातोय? त्या शार्प पॉइंट्समुळे. शार्प पॉइंट पाशी चार्ज निघून जातोय. कन्व्हेन्शनली आपण म्हणतो की इंड्यूस झालेला पॉझिटिव्ह चार्ज निघून जातोय. प्रत्यक्षात ढगातला निगेटिव्ह चार्ज जमिनीकडे जातोय. क्षणार्धात जाण्याच्याऐवजी सावकाश थोडा थोडा करून हा जातोय. सो क्लाउड इज डिस्चार्ज continuously instead of suddenly, and so the loss of property and loss of life is avoided because there is no lightning flash and the energy goes slowly. The charge is given to the earth continuously, slowly, not suddenly, all of a sudden. So, student friends, I have tried to give you as many concepts of electrostatics as possible. think this carefully, read more, and get a better, thorough understanding of electrostatics. Thank you. Please utilize this opportunity given to you by a series of lectures arranged by MKCL. I am sure you will develop good confidence by taking advantage of number of such lectures supplied to you by MKCL.